welcome to True Projects. In this video, we are going to explain about the project, which is CreditCoin, a privacy-preserving blockchain-based incentive announcement network for communications of smart vehicles. Introduction of the project. The project focuses on creating a secure and privacy-conscious vehicular announcement network called CreditCoin. This network utilizes blockchain technology to incentivize users to share location and event data, addressing privacy concerns and improving the reliability of information sharing among smart vehicles. Traditional methods of vehicular announcements like privacy protection fail to motivate users to share location information effectively, resulting in potential privacy breaches and unreliable data sharing. The project addresses these drawbacks by incentivizing user participation, implementing blockchain for data security and privacy, and also preventing incentive lock through daily expiration. Blockchain is a distributed ledger technology that serves as a secure and tamper-resistant system for storing and verifying vehicle communication details. It ensures data security and privacy preservation by using cryptographic techniques and prevents unauthorized tampering with the stored information. There are many types of blockchains such as Ethereum, Bitcoin, Stellar, Ripple, etc. Each has its unique features, governance models, and target use cases. We are using Ethereum in this project. Ethereum goes beyond just recording transactions. It allows developers to create small computer programs called smart contracts. These smart contracts, without the need for a centralized authority, a legal framework, will manage tasks like storing and getting evidence data. Ethereum's strengths include its ability to create various decentralized applications and its active community of developers. Objective of the project. The project's goal is to improve vehicular announcements by tackling privacy issues and motivating user engagement, all accomplished by integrating blockchain technology. Blockchain is utilized in this project to provide a secure and tamper-proof ledger for storing vehicle communication details. It is used to protect user identities and data, verify data integrity, and prevent unauthorized tampering. Symmetric ring signatures are employed in this project to ensure user privacy. They enable the creation of a secure signature that conceals the identities of both initiators and repliers involved in the vehicular announcements. This cryptographic technique enhances privacy by preventing the exposure of sensitive user information. For implementing this project, we need hardware and software requirements. Coming to hardware requirements, processor of 5 and above, RAM of 8 GB and above, and ROM of 25 GB and above. In software requirements, we need Node.js, Python of 3.7.0 version, and Visual Studio Community version. To implement this project, we have designed various modules in the methodology. The first module is role settings. This module defines various user roles in the system, including initiator, the vehicle which sent request, replier, the vehicle which replied to the initiator, trusted authority, which is responsible for key management, and the verifier, which is trace manager, which will perform verification. Packet settings. This module determines the types of packets generated based on the user roles, particularly echo announcement packets as request or reply. Request packet. It is sent by an initiator to request information from a replier. Initiating an announcement, the replier must agree to participate. Reply packet. It is sent by replier in response to the request packet, indicating their willingness to join the announcement with the initiator. Announcement aggregate packet. It is sent from the initiator to verify for the verification purpose, aggregating information related to the announcement. Generate key trusted authority. This module is responsible for generating and managing cryptographic keys. The trusted authority likely handles key management for encryption and decryption process. Run CreditCoin simulation. In this module, the initiator vehicle sends a request to nearby repliers, incrementing incentives for participating repliers. Trace manager verification. The verifier reads all blocks or packets and performs verification. This involves checking the hash codes of previous blocks to ensure data integrity. Computation time graph. This module generates graphs that display computation time for various operations such as request and reply packet transmission and key generation. These graphs help in analyzing system performance. Blockchain integration. Blockchain is used as a foundational technology to store and secure vehicle communication details. Each piece of data, such as announcements and transactions, is stored in blocks within the blockchain. To ensure privacy, user data and identities are encrypted using symmetric encryption technique before being stored on the blockchain. This protects user information from the unauthorized access. Blockchain provides a tamper-resistant ledger. All blocks in the chain are associated with a unique hash code, and the blockchain verifies the hash codes of previous blocks before adding new data. If the verification is successful, the data is considered secure and intact. For execution of the project, first we need to open the code folder which contains source code files. This is the CreditCoin contract. This file consists of a Solidity code. It handles data structures, functions and events with modifiers for validation. Now we have to open HelloETH folder. This is the node module folder which contains dependencies or modules needed for our project. We have to open this. This is the bin folder. This contains executable scripts related to project dependencies. We have to open it. This is the run blockchain.bat file, which is a Windows batch script to start blockchain. This script will initiate the local Ethereum blockchain for development purpose. We have to double click on it to start the blockchain. Blockchain is hosted on the local machine at the address which is localhost and the port number. This is the localhost and this is the port number. This address allows us to interact with the blockchain using various tools and applications. So here we will execute a command which is truffle space migrate. Now we need to click on enter. This will compile and deploy smart contract. Truffle is a development framework for Ethereum that simplifies the process of compiling and deploying smart contracts. After running the migration, we will receive a unique contract address. This is the unique contract address. This address represents the location of our deployed smart contract on the blockchain. And here we have gas used. To execute the Solidity file and compile smart contracts, this is the amount of gas consumed. Now we have to return back to the main directory. This is the run.bat file. Instead of executing the project through command line interface, we have created Windows bat file to execute the project. So we have to double click on it to execute the project. This is the graphical user interface of the project. With this GUI, we can interact with the program. And this GUI is created by using the Tkinter library. Here we can see a drop-down box which contains vehicle IDs, and here we can enter any message to send to other vehicle. So from the drop-down box, I'll select 8 as the initiator vehicle ID, and in the text field I'll enter So here I entered the message. Now I will click on Create Vehicle Network button to create simulation screen. So here, from the simulation, all the red color circles represents the vehicle and the blue color circle represents the cloud server. Now we need to click on Trusted Authority Key Generation button to generate keys for encryption. In the text area, we can see keys are generated. Now we need to click on Run CreditCoin Simulation button to allow selected initiator to send requests to the nearer vehicles and get reply. So I will click on Run CreditCoin Simulation. All the data will be stored in blockchain, so it will take some seconds to give the reply. We can see initiator, which is V8, repliers are exchanging announcements between each other and cloud server. In the text area, we can see which initiator sending to which replies. So here we can see that initiator 8 is sending replies to replier 3 and replier 5. All this data will be saved in the blockchain. To read and verify, we need to click on Trace Manager Verification button. In the text area, we can see decrypted vehicle ID involved in announcement with their X and Y location, date and time and verification hash code, and incentive values. If hash code mismatches, then verification will fail. We can scroll down to see all other vehicle details. Now we need to click on Computation Time Graph button to get graph for each vehicle request, reply, sending and verification time. So I will click on Computation Time Graph. So here on the x-axis it represents the request number and y-axis represents computation time that is required for sending request, reply and verification. Now we will close this. In this way, A one vehicle can send to other vehicle information securely from the blockchain. Now we will close this GUI. Conclusion of the project. This project has significantly improved the effectiveness of vehicular announcements by addressing privacy concerns and motivating user participation. The utilization of blockchain technology has played a pivotal role in ensuring the security and confidentiality of vehicle communication data while maintaining its accuracy. The project has successfully protected user privacy by employing symmetric encryption, preventing unauthorized access to their sensitive information. Through the introduction of incentives and measures to prevent incentive lock, users are actively encouraged to engage in sharing location and event data. The tamper-resistant nature of the blockchain ledger guarantees the reliability and integrity of vehicle communication details, enhancing the overall trustworthiness of the system.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.